So today, before we go any further, we're going to take a little bit of a step back, and this is just one type of equations that we didn't solve when we were in P1. And so this is a rational equation. And basically a rational equation is just an equation in which one or more of the terms is fractional. Now two of my three terms here is fractional. This is in fact a rational equation. So it's just really a fraction they're fractions, but we're just not sure what they are. So a couple of things that we have to be careful about. The primary thing that we need to be careful about is this has domain restrictions on it. So I need to be aware that n equals -8 and n equals -1 are not part of the domain of this rational equation, right? Because in plugging in either one of these things would give me a division by 0. So one way to solve them, and I find that this is the easier way to do them, is to figure out what the common denominator would be and then just multiply all the terms by it. Now we have to remember, because we're going to multiply away the denominator, that if we get either one of these values, then we throw it out because it's actually not part of the domain. So what I mean is, if the first thing that I would do is if I had things that were factorable in the denominator, that's the first thing that I would do is factor them, because I want to see all the terms in their simplest form in the denominator. Now these are both linear, which can't be factored. So my least common denominator, this we can assume is 1 over 1, right? So it has a denominator of 1. So I need all of the factors that appear in the denominator as my least common denominator. So I'm going to write over here that my least common denominator is both n plus 8 times n plus 1. We need both of them. So this is what we want our least common denominator to be. So one option is to make these each have the common denominator I want and then work with the numerator. I think it might just be easier for us to just multiply each one of these terms by this. Okay, so I'm going to multiply this side by n plus 8 times n plus 1, and the same over here with parentheses. So n plus 8 times n plus 1. All right. When I multiply this side, this term, the n plus 8 cancels, and I'm left with n plus 1 here times the quantity n plus 5, which was already there. So I'm left with this times this over here. Now I distribute. So this times this, so 1 times this is just that thing. So I'm just going to write it as n plus 8 times n plus 1. And then plus, now I'm going to have 6 times this. Okay, so here when I multiply this n plus 1 will simplify with this n plus 1, and it will leave me with 6 times n plus 8. All right, now I have a bunch of parentheses now that I need to open, but you notice my denominator is gone. So I need to make sure that I'm really thinking in the background that if I get either one of these values, that I can't use them. All right, so let's do some simplifying here. So the first thing I'm going to do is multiply this out. So this will be n squared plus 6n plus 5. And then I have this times this, which will give me n squared plus 9n plus 8. Then I have 6n plus 48 over here. All right, so let's simplify the right-hand side over here. This side I'm not going to do anything to because I don't have any like terms. But over here I have a 6 and a 9n giving me 15n overall. And then an 8 plus a 48 gives me 56. All right, so I want to get all my n squareds on both sides. I notice, oh wait, as soon as I subtract 1, all my n squared terms are gone. So that just leaves me with 6n plus 5 is equal to 15n plus 56. There is some algebra involved here. Right, so now, because I like my n's to be positive, I'm going to subtract 6n from this side. So I'm going to get 9n on this side is equal to, I'm going to subtract 56 from this side and get negative 51. And so my answer is negative 51 over 9. Now these are both divisible by 3, so n is negative 17/3 in its very simplest form. So the last thing that I need to do is just check and make sure that I didn't use anything I'm not supposed to. So this isn't 8, negative 8, and it's not negative 1, so this is a solution. Okay, so let's move on to a more interesting one than that. Okay, so this time we're going to look at, so this one we're going to have to work a little bit harder for. So we have 1 over x minus 2 and is equal to 3 over x plus 2 minus 6x times x squared minus 4. All right, so before I would do my common denominator, I want to factor anything that I see that can be factored. And in fact, this x squared minus 4 can be factored as x plus 2, x minus 2. See, if I didn't notice that, I might have been tempted to think my least common denominator was all 3 of these, and then my values would be so big and I'd have really large values. I'd have like x to the 4th in the end, and I don't really want to solve x to the 4th. We know how at this point, but that doesn't mean we should if there's an easier way. So my least common denominator, you notice, this has both of these. This one, right, these two match and these two match. So as long as neither one of these occur in more than one term at once, like if this were x plus 2 quantity squared, I can just use the ones that they have in common. So I have x plus 2 times x minus 2. This is what I would want my least common denominator to be, and so that means I'm going to multiply, like I did before, my entire rational equation by this, remembering at that time that x cannot be negative 2 or positive 2, right? Because that would cause me to divide by 0 in either any of these. Okay, so let's multiply. So this gets my x minus 2 times x plus 4, or x plus 2, I'm sorry, I don't know why I said 4. Okay, so when I multiply this side, the x minus 2's cancel, and I'm left with 1 times x plus 2. And now I'm going to multiply both of these by x plus 2 times x minus 2. All right, so when I multiply this times this one, then I get the x plus 2's cancel, and I'm left with 3 times x minus 2. Now the good news about this last term is that it has both of these terms, so when I multiply it, they both simplify and just leave me what was on top here, minus 6x. Okay, so now I'm ready to open up some parentheses. I have x plus 2 is 3x minus 6 minus 6x. And let's see, I have x's both on this side, so I can write negative 3x minus 6 is equal to x plus 2. I'm going to add 3x to both sides. This is going to give me 4x plus 2 equals negative 6. And now I'm going to add, or subtract, 2 from both sides. I get 4x equals negative 8, and I end up with x equals negative 2. Oh, but wait, right? But negative 2 I cannot use, because when I try to go put negative 2 in, guess what? When I put it in here, I'm dividing by 0. So that was the only solution I got, and since it doesn't work, this is a no solution. Okay? So that is our technique for solving rational equations.